Why do some image layer in Docker appear as missing? I asked this question last night also on LinkedIn. So what do I mean by that? So let's go to this and let me run this Docker image ls. And there's a command called Docker history in CentOS. Okay. So here, if you see, so I will talk about that image architecture. But if you see, there are some of the images where you see it's missing. Anyone know what is the use of this missing column or why this missing column is there? In the meanwhile, let me go to the Docker Hub. Yes, Mohit is correct. Docker images combine some of layers. Yeah, that may be the reason of missing. Any other reason? So let's talk about something called Docker images. Okay. So images is basically a layered architecture. So what do I mean by that? So basically, if you look at any images, it is basically what you define inside a Docker file. So let me give you Docker file. I think I have a bunch of examples, but let's take any of these examples from here. So this is one of the standard Docker files. Okay. Here you will see that we have this from directive. So from means from where exactly does your source of image, from where exactly you are going to get that image. So for building any container, you need some scratch image, right? So for example, if you want to install Apache, you need to have some kind of operating system. On the top of that, you can install that operating system, right? There are some exceptions. There's something called a scratch image. I'm going to discuss about that later. But you need something on the top of that, you can install something, right? So there you have something called a base image, which is defined the from instruction. Then you have something called a work dir work, which is stand for work directory. So basically, this is your application directory, where exactly the code of your application lies. So here you're defining this one. So basically, I will not go to the syntax of a Docker file. What I will tell you that each of this description or what we are defining inside the Docker file, it's going to create a layer. So I will say, let me copy this one. So this will be your layer one. And actually it is the opposite way. First, it is going to create this layer. Then it on the top of that, it is going to create the layer two, then layer three, and so on. Okay. And all these is going to be a read-only layer. Okay. They all will be stacked up. And once it's done, let's say this is going to be a layer six. It's going to create, when you start a Docker container, like the way we have seen it here, where somewhere here, that it is first trying to pull the image and then it is going to create the container. We have seen it somewhere. Okay, I will run a new container just to show you. That is run open and anything. So you see that first step, it is always going to pull that image for you, right? So that's what I want to show you guys. This is the image which is it is pulling. And when you run that Docker container or Docker run command, what it is going to do, it's going to create an image called a read write layer. And let's say in this layer, you are making some changes. So what it is going to do, it is going to copy that image layer or copy that content of this to this read write layer. And this concept is called COW or copy on write. And all the changes is going to happen on this read write layer. And once you shut down the container or once you're done with your work, this image is going to be, or this layer is going to be wiped out. So your Docker image is always been on the pristine condition. There is no change on the original image. Okay. Now coming back to our main question, like why some of these layer or some of these is showing as missing. So there may be a several reasons for that. First thing is that the Docker daemon. So if you look at here, there's a command. I mean, either you can do Docker version, right? I'm running 20.10.25. So the version through which this image was created, for example, we can take any of this image. Let's say in this case, the version which has been used to create this image or this particular layer. Now you guys have understand the layer. Like, and layer is one of the instruction in your Docker file. It's created with a different version of Docker. And that's what when it is trying to interpret in your local system. So this Docker history command is basically a running on the top of a image which is present in your system. Okay. And basically it's present inside something called where live Docker directory. Okay. I use sudo. So this is a default location where the images are present. So when you downloaded those images, it's basically stored inside this directory. Overlay file system. Overlay 2. And there you have all these images. Okay. So this Docker history command is basically going to read from this location and trying to see if the version of Docker, for example, in this case, Docker version 20, is going to be if it's going to be the same as what the guy who built that image, if he used the same version, then it will show the image hash in front of it. Otherwise, you will always see this missing. Okay. In some of the cases, the person who created these images, if you try to combine those layer of images, then you will also see this as a missing. Some of the reason why you will see missing as a tag, but in case if it will be the same version as what you are running, you will see that image hash ID on the top of it. So again, it's not a technical question, but it's more of a curiosity if you want to know why these things happen behind the scene. Okay. Any questions so far before I move to one scenario-based question, and that is going to cover a lot of your doubt or a lot of the question which is generally asked during the interview. Any questions so far?
Prashant, just one quick clarification. So is
Sure.
it the reason why those two layers are showing as missing because those are like the intermediate steps that are being applied to the, I guess, the base image? That's why they're missing?
I will, that's the thing. It's like we are not sure that this is the intermediate step. So one reason that I've told you, maybe the version of Docker is different from from the person who created this image. There may be a possibility. So like Himanshu has mentioned, right now we are looking at the CentOS. So here we are looking at the latest tag. Okay. And that's what we are going to discuss in the next section about this latest tag and everything. So if you click on this latest tag, basically you will see all the image layers that is been created. So here it is not clear that the guy who created it is he squashed those layers, or from where is exactly the from instruction and everything. So David, that is still a mystery.
Okay.
Okay, there's one more command I can show you guys, which is called Docker inspect. And let's say for CentOS. And this will basically a JSON output that is going to give you a much more information about each and every layer which is present on this particular image. Okay. And you can see over here, merge directory, upper directory, work directory. It will give you some amount of information, but not everything. So just throwing you out this idea. Okay. Entire command. in the layer, that's what I told you. You can use this Docker inspect and you will get more information about the layer. The problem is that when you are pushing the Docker file, I mean, there is no way to get the, for example, okay, let me show you this. Okay, and open to, oh, sorry, not Docker image, Docker history. So the problem is it is difficult to do a reverse mapping, Mohit. So for example, I will say that, okay, the directory which I've showed you, where lib Docker, whatever it is, I expect that inside that I have some this kind of a hash, and inside that hash I will see, okay, we have this particular binary. So for example, the simple example I can give you, that this from instruction, right, where we are getting the image, right, original base image. And original base image, I will believe that it will have some operating system stuff like root directory, the bin directory, and all those things. But the way Docker handled this is like it is going to encrypt it, and it is going to have a different kind of a like when you are going to push this image to a remote Docker repository, it is going to create a different, completely different SHA hash. So from here you can see, okay, this is what which is present in your system, because I told you Docker history is for your local history. I mean, whatever which is present in your system. But if you try to do the mapping into a Docker hub where you have a completely different SHA hash, it's really difficult to do a reverse engineering. Okay, for this layer, what exactly is present?